Welcome to my channel. If you find my videos helpful, please subscribe and share them with your network.
Integrity and performance, making it essential to identify the causes and mitigate them effectively. Common causes of round defects in HDPE pipe coils. 1. Manufacturing defects. Die imperfections. Issues with the extrusion die during manufacturing can lead to defects such as round marks or bumps on the pipe surface. Cooling problems. Uneven or improper cooling during production can cause localized changes in shape, leading to circular deformations. Material contamination. Impurities or foreign particles in the HDPE resin can result in localized defects. 2. Mechanical stress. Excessive tension during coiling. If the pipe is wound too tightly during the coiling process, it may develop round impressions or kinks. Handling damage. Rough handling, dropping, or stacking during transport and storage can cause round dents or indentations on the pipe. 3. Thermal expansion and contraction. HDPE is sensitive to temperature changes. If pipes are coiled or stored in extreme temperatures, they might develop round defects due to thermal expansion or contraction. Improper storage under direct sunlight can exacerbate this, causing uneven stress on the coils. 4. Incorrect coiling tension. If the coiling machine applies uneven tension while winding the pipes, it can cause localized pressure, leading to round marks or defects on the coil. Potential solutions to prevent round defects. 1. Quality control during manufacturing. Inspect the extrusion equipment regularly for any imperfections in the die. Ensure uniform cooling processes to avoid thermal stress or uneven shaping. Use high-quality HDPE material to prevent contamination-related defects. 2. Proper coiling techniques. Adjust the coiling tension to avoid excessive stress on the pipe. Use a larger bending radius during the coiling process to reduce pressure. 3. Safe handling and storage. Avoid rough handling, dropping, or compressing the coils during transport. Store coils in shaded areas to prevent temperature-related expansion or contraction. Stack coils appropriately to avoid applying uneven pressure. 4. Regular inspection. Conduct visual inspections before and after coiling to identify any defects early. Use non-destructive testing methods, such as ultrasonic or visual inspection, to detect internal defects that might not be visible. Impact of round defects. Round defects in HDPE pipes can lead to weak points. These defects might act as stress concentrators, leading to early failure under pressure. Reduced flow efficiency. Internal round defects can create turbulence, reducing the efficiency of fluid flow. Structural integrity. Surface defects can make the pipes vulnerable to external pressures, potentially causing cracks or splits over time. Preventing round defects in HDPE. High-density polyethylene pipes requires a combination of good manufacturing practices, proper handling, and effective storage. Here are some key strategies to reduce the risk of round defects. 1. Optimize manufacturing processes. Quality raw materials. Ensure the use of high-quality, pure HDPE resin to minimize the risk of impurities that can cause defects. Use well-regulated suppliers for consistent material quality. Proper extrusion temperature. Monitor and control extrusion temperatures closely to ensure the HDPE material flows smoothly without causing internal or external defects. Die and extruder maintenance. Regularly inspect and maintain the extrusion die and equipment to avoid any imperfections that could lead to round defects. Replace worn-out or damaged parts immediately. Even cooling. Use consistent and even cooling after extrusion. This includes implementing a well-controlled cooling system that prevents uneven contraction, which can lead to shape deformities. Ensure the water bath or air cooling is functioning properly. Process monitoring. Use sensors and automated systems to continuously monitor pressure, temperature, and other critical parameters during production. This helps identify problems early. 2. Proper coiling techniques. Tension control. Adjust the coiling machine to apply consistent and appropriate tension to prevent overstretching or compression that can cause round marks. Use automated systems to monitor tension levels. Larger coil diameters. Use larger coil diameters to reduce stress on the pipe. This decreases the risk of forming round defects due to tight bending. Correct coiling speed. Ensure the coiling speed is adjusted to match the extrusion speed, avoiding excessive pulling or slack that can cause kinks or impressions. Use guides. Implement guiding mechanisms that lead the pipe smoothly onto the coil without creating localized pressure points. 3. Handle and store pipes with care. Gentle handling. Avoid rough handling during transportation, which can cause dents or impact damage. Use proper lifting techniques, such as slings or forklifts, and avoid dragging or dropping coils. Even stacking. Store coils evenly and avoid stacking them too high to prevent the lower coils from being compressed by the weight above. Temperature control. Keep pipes and coils away from direct sunlight and extreme temperatures. Consider storing them in a shaded or controlled environment to prevent expansion or contraction stress. Protective packaging. Use protective packaging, such as wraps or covers, to shield the pipes from physical damage during transit or storage. 4. Implement quality control measures. Visual inspection. Conduct regular visual inspections at different stages of manufacturing and after coiling. Use trained personnel to spot any defects early in the process. Non-destructive testing. NDT. Use advanced inspection methods like ultrasonic testing or laser scanning to detect any internal defects that might not be visible. Quality assurance tests. Implement hydrostatic pressure tests, dimensional checks, and surface finish evaluations to ensure the pipes meet the required standards. Standard operating procedures. SOPs. Establish clear SOPs for each stage of the process, including handling, coiling, and storage, to ensure consistency and quality. 5. Training and equipment. Employee training. Ensure that personnel involved in manufacturing, handling, and storage are well trained on best practices to prevent defects. Proper training on machine operation and maintenance can reduce human errors. Use modern equipment. Invest in high-quality, modern machinery for extrusion and coiling. Updated equipment can provide more precise control and better monitoring capabilities. 6. Periodic maintenance and calibration. Regular equipment checks. Schedule regular maintenance for all equipment involved in the manufacturing and coiling process. Well-maintained MAC and coiling process. Well-maintained machines reduce the risk of defects caused by mechanical failures. Calibration. Periodically calibrate sensors and monitoring systems to ensure accurate readings during production. 7. Consider pipe design adjustments. Wall thickness. Ensure the HDPE pipes have adequate wall thickness for their intended application. Thicker walls can resist deformation better, reducing the risk of round defects. Additives and modifiers. In some cases, consider using additives or modifiers to improve the flexibility or strength of HDPE, which can help minimize defects during coiling. By combining these strategies, you can significantly reduce the occurrence of round defects in HDPE pipes, ensuring high-quality output and better durability in their application.